Steel is produced from either scrap steel or pig iron, which is obtained from the blast furnace. Depending on the grade of steel, overall cost-effective availability of raw material, steel could be produced using the electric arc furnace, the open heart furnace, the oxygen converter, etc. Have you ever wondered as to why there are many categories of steel? Some of these steel are used in the automobile industries. Some categories could be used for structural applications as reinforcement, while some could be used in the machine shop as cutting tool. It is majorly the carbon content and alloying element that contributed in determining the type of steel that will be produced, hence the application it is best suited for. In this presentation, we will be talking about steel, precisely carbon steel. Stay tuned. Start by introducing steel. Steel is basically an alloy of iron and carbon with small percentage of alloying element. These alloying elements, their main function is to increase or to alter the properties of that steel. Such alloying elements include cobalt, nickel, molybdenum, tungsten, carbon, etc. Steel is a hard, pliable, ductile, and malleable solid, which is probably the most solid material after plastic and iron. So we can see that steel is equals to iron plus carbon plus alloying element. So the definition of steel is an alloy of carbon and alloying element. Now the reason why we have different categories of steel is because of this carbon content, alloying element, and the mode of production. You get to know that there are 4 categories of steel as categorized by American Iron and Steel Institute, and the major reason why we have those categories is because of this carbon content, alloying element, and the mode of production. According to AISI, steel can be classified into 4 categories, and those categories could easily be remembered using an acronym, which is CAST. So American Iron and Steel Institute has classified steel into 4, and this could be remembered using CAST, where the C stands for carbon steel, A stands for alloy steel, S stands for stainless steel, and T is tool steel. Let me just clean this. Steel. For the purpose of this presentation, we will be looking at carbon steel. Now, classification of carbon steel. This carbon steel is a type of steel that is categorized based on the carbon content. It is the carbon content of this particular material that made it become carbon steel, and this carbon steel is divided into majorly 3 categories. We have the mild steel, also known as the low carbon steel, we have the medium carbon steel, and we have the high carbon steel. If you check our iron carbon diagram, quickly this. If you check our iron carbon diagram, this will come here. So this is austenite. Now, The iron carbon diagram, if you are asked to draw the steel portion, this is 2.1, this is 0.8, 0.02. So from here to here, we'll have steel. So if you're asked to draw the steel portion of the iron carbon diagram, this is what you are expected to draw. So within this, we have temperature here, and this is 723 degrees Celsius. This is 910 degrees Celsius. That is the austenite region. And then here is 2.1%. This is 0.8%. So if you take this steel portion over here, that is where we'll be using this is what we'll be using to differentiate this steel from each other. Now, the classification of carbon steel depends on its carbon content, and we have three major types. We have the mild steel, we have the medium carbon steel, we have the high carbon steel. Now, the low carbon steel. The low carbon steel is a type of carbon steel which contains carbon of about 0.15% to 0.3% carbon. It is also known as mild steel. Now, because of this low carbon content this material is having, it is very, very ductile. This material is a very ductile material. It has good formability, it is weldable, and it has low strength. Because of the carbon content, this material is not hard. As such, there is a problem of wear, so it easily gets wear. And for us to overcome that wear, we do what we call diffusion hardening. Example of those type of steel is ASI, that is American Iron and Steel Institute, 1008, 1010, 1015, 1018, 1022, 1018. So on this carbon diagram, we said the carbon content of low carbon steel is within the range of 0.15. So let me say this is my 0.15, somewhere around here, 0.15, somewhere around here, to 0.3. So this region is low carbon steel or mild steel. So within this region, that is 0.15 to 0.3, we have low carbon steel, which is mild steel. And we said it has good formability. Because of low carbon content, it is having high weldability. Another disadvantage of this low carbon steel is that it does not respond well to heat treatment. And why? Because of the low carbon content. And if this material does not respond to heat treatment, how then do we increase its strength or improve its strength? Is by cold working. When you cold work this material strength is increased, but low carbon steel does not respond well to heat treatment. And applications of low carbon steel is structural application. We all know this is mild steel, which is used as reinforcement in structural application. So application of this is you can use it as reinforcement. Okay, so the next type of carbon steel that we'll be looking is the medium carbon steel, MCS. The medium carbon steel is a type of steel that contains carbon content within the range of 0.3% to 0.6%. As we are seeing that this carbon content slightly increased as compared to low carbon steel, this material is having moderate to high strength with fairly good ductility. It can be used in most machine elements to produce crankshafts, to produce rail tracks, to produce railways, because of the moderate carbon content it contains. And with this carbon content, this material is slightly responds to treatment, slightly, unlike the low carbon steel. This material again is slightly weldable when compared to low carbon steel. And if you check our phase diagram, this is 0.3 and this is 0.6. So within this range, we are going to have our MCS, that is medium carbon steel. An example of this is ASI 1030, ASI 1050, ASI 1060. Now, this material can also add chromium, nickel, molybdenum to improve the heat treatment capacity. Remember, I said the low carbon steel does not respond well to heat treatment, but this material, because of its slight increase in carbon content, it slightly responds to heat treatment. But for us to increase that capacity or capability, chromium, nickel, molybdenum can also be added to improve that property. But this material, one of the disadvantages is that it is difficult to cold work, but it is very good when it is hot work. Application of this material is it can be used to produce crankshaft, it can be used to produce high duty spring, or you can use it to produce rail tracks, you can use it to produce railways. An example of that is ASI 1060, ASI 1040, ASI 1030. The next classification of this carbon steel is the high carbon steel, HCS. High carbon steel is a type of steel that contains carbon content within the range of 0.6 to 1.5%. So we say this carbon steel is from 0.6 to 1.5% carbon. So this range is high carbon steel. So when a material is having lower elongation, it means that material's ductility is very, very low. And when we compare these three materials, low carbon steel, medium carbon steel, and high carbon steel, we will be seeing that the high carbon steel elongation is very low, meaning its ductility is the lowest. This material can be quenched hard, and it can be used in applications such as tool, knife, chisel, for die forging operation, where die is required of high wear resistance. And it can also be used as implement for machineries, that is our tractors. Because of its high hardness and strength, and it is also least ductile. So with this high carbon steel is used in application whereby high strength, high wear resistance is required, and it is also used in tempered and so some of the examples of this high carbon steel is the ASI 1080 and ASI 1095. Another application is that it can be used as cutting tool in our machining lab or machining workshop. So these are some of the applications of high carbon steel. This is a cutting tool used by carpenters, and this is our rail track. The wheel of the rail could also be produced using high carbon steel. Now, in summary, we said steel is an alloy, right? And we said again, steel is a ferrous metal. Steel is a ferrous metal. And we said steel is classified into 4 categories according to ASI, American Iron and Steel Institute, using the acronym CAST. Classify steel into 4 places, into 4 categories. We have the carbon steel, we have the alloy steel, we have the stainless steel, and we have the tool steel. We further say this carbon steel is divided into 3. We have the low carbon steel, we have the medium carbon steel, we have the high carbon steel. I will say this low carbon steel is a type of steel that contains carbon within the range of 0.15 to 0.3% carbon. This medium carbon steel is a type of carbon steel that contains carbon content within 0.3% to 0.6%. And lastly, the high carbon steel that contains high amount of carbon is having carbon content of 0.6 to 1.5% carbon. And because of the presence of this carbon, it gives them different property and different application. So these are some of practice questions with respect to this presentation that you can use to test the understanding of this presentation. The first one says, what kind of carbon steel would you suggest as a consultant engineer to a business that specializes in the production of forging dies? Second one says, heat treatment has no much effect on low carbon steel. Of course, heat treatment has no much effect, or low carbon steel does not respond well to heat treatment. Why is that so? And how can its strength be increased? Third one said, steel is an example of what metal? Of dash metal. Okay, that's a straightforward question. Fourth one, what factors lead to the various steel classifications? Yes, we said we have four categories of steel. We have the carbon steel, we have the alloy steel, we have the tool steel, we have the stainless steel. What are the factors that lead to that various classification? Right, this is all I have for you today. Please subscribe and press this bell icon so that you get notification on any video that I made. Thank you for watching. See you in my next video.